we're going to look at actually evaluating the limits algebraically, right? And this means by means of a formula. Okay. Will this always work? What do you think? Who says yes? Raise your hands. Will it always work being able to evaluate a limit using a formula? Who says yes?
Possible.
Okay, who of you says no?
But
Are you on the fence?
too much.
You say no. Okay, very good. Now, the reason we say it will sometimes work and sometimes it won't work, we've previously looked at two functions. We looked at a function like this one, as you can see over here. And it's important to note that this type of function is considered a discontinuous function. What's it?
Discontinuous.
Actually, that's not actually the proper mathematical term. Okay? But for our purposes, let's just put it in inverted commas and say it's a discontinuous function. We consider this function to actually have something called jump continuity. Jump continuity. Do you know why? Because you run on the function and then you have to jump. Very good. Okay. Okay. I'm not sure if that's the reason, but anyway. Then this function here, if this thing was closed, then we consider this function what? A continuous function, right? Okay, now there are different types of continuity. For example, if it was closed or if it was open. Now I have a question for you. If this function is represented by a formula, what's one way that you can find the value of 10 if it wasn't written here, but you had the formula for this graph?
Maybe secret 5.
You put 5 in the x value and then you should get out 10. And that's exactly what we're going to be looking at now when we evaluate limits, right? For grade 12, we are only considering evaluating limits algebraically, which means we are given a formula, right? And people, you won't see limits graphically in an examination, but you may see them in my papers, okay? And it has been in the Sakai paper in the past as well. So it's good we're covering it.
So how do you define in the formula?
That's what we're going to look at next, right? Okay. Okay, so firstly, let's just recap on this. We had jump continuity and then we had a continuous function. And now we're saying if you have what type of function? A continuous function or a function that has nice continuity. Now what do I mean by nice continuity? I mean it's not jump. So maybe it's an open circle, but it's only at one point. Do you see that? Which means if you put this in a formula, if you have the formula, although the function is not defined at that point, if you put 5 in the formula, you'll still get out 10. Whereas in this particular function, you can't put 2 in and get 6 and then put 2 in and you get 9. Because there might be two different formulas for the different parts. Are you guys with me? Okay. Now I'm going to give you some nice steps to evaluate limits, and then we're going to look at examples thereof. So, you draw this out. Step 1. I'm going to call the method, I'm going to name it something quickly. If you have a formula for the function and you insert the value, we're going to call it plug and chug. Okay, so as we said, it's the what method? Plug and chug, which means you're going to take the value that it approaches and you're going to put it into the formula. Now I have one question for you, because I said grade 12 only deals with functions that have this nice continuity, like you have an open dot and the function moves on. Or you have no open dots, you just have a completely continuous function, right? Do you think we are going to be evaluating partial limits?
No.
Left hand side, right hand side?
Yes.
No.
No, we don't.
Because these functions they're not jump continuous.
Also,
It's always going to, it's either going to exist or it's not going to exist. Right? Because of the functions that we are looking at. Right? They look like this one. They look like this function. Okay? Doesn't matter how they look, but they have one small open dot. Okay. So plug and chug, I'm going to write at step 1. Step 1. Right? Okay, let's see nicer colors. This violet seems to be working out. Step 1 is the following, is you're going to substitute, right? So for our purposes, you will always just substitute the x value that it's approaching. Okay, very good. Now, let's draw an arrow. Then this turns into, you're either going to find 3 different types of results, and I'm going to list them here. and then we'll tell you what you do there. Okay. Sky blue, no, we've had that earlier. So the first thing you're going to get is type 1, right? Either that limit is real. So what this means is when you insert a value, so type 1 means it's real. If you substitute in the value and you get out a number, then it means that your limit exists, right? The second type is
Non-real.
the limit, I'm going to put here type 2, right, where it's undefined, okay? And we're going to look at examples of each of that. And then type 3 is what we call an indeterminate form, which I'm going to teach you how to solve as well. So type 3 works as follows. I'm going to call this an indeterminate form. Indeterminate. So what is this indeterminate form that we are considering? Well, the indeterminate form is when you have something 0 divided by 0. Okay? Right. Now, guys, I'm going to show you if something is real, you have your answer and the limit is done. If you have type 2 and it's undefined, the limit's done, it doesn't exist. Right? It means that it doesn't approach a specific value, it means it's approaching infinity. That's when you're getting a limit towards an asymptote. You understand now? Okay? Asymptotic limits, right? And an indeterminate form is where you have 0 over 0. If this happens, after you immediately substitute, then you're going to factorize and then you repeat steps from the beginning. Now, what do I mean by repeat? You first factorize, cancel out what you must cancel out, you resubstitute. If you still end up with 0 over 0, then what must you do? You factorize again and substitute until you get either a real number or it's undefined. Okay, factorize and repeat. So those are our steps, and in the next video we're going to look at a few examples quickly.